Dear students, I welcome you all for the next academic year. Now in your 10th standard, this particular chapter optics, it plays a very important role. Okay. So here, let's see what do you mean by this optics. So this optics, it's a branch of physics. It is a branch which deals with the study of light. Okay. So that's what we mean by the term optics. Optics is nothing but the study of light. It is one of the branches of physics which deals with the study of light. And in this thing, what you learn, actually we are going to learn in light. What we are going to learn, that we can divide into two things. One is the nature of light, that is what is actually light, that is what is nature of light, and how this light behaves under various circumstances. It means when a light is passing through a medium, when it is entering into some other medium. Okay. In that case, what will be the behavior of light? Whether light takes up the same straight line path, or whether any changes in the path of light, whether it is sent back or it is passing through it, and if it is passing through it, what happens to the velocity or wavelength or frequency of light. About all those things we are going to learn. Okay, so first let's see what is the nature of light. Okay, we'll try to understand what is actually light. Okay, so here, this nature of light. If I ask you what is light, then you say, now you'll be able to say light is the form of waves. Okay. You will be having an answer readily, that because since you are learning about this light right from your 6th standard, if I ask you what do you mean by light, then you say it is a form of energy or it is in the form of waves. Some of you might say that it is an electromagnetic wave. You can go for one step ahead, and some of you may answer that it is an electromagnetic wave. Okay, and still some of you may be able to say that light is you may be able to say the velocity of light as c is equal to 3 into 10 power 8 meter per second. Okay, so all those things you may be able to say about light, as we are learning about this light right from 6th standard. Okay, first let's see, we'll just see in detail about what do you mean by this light. Okay, so we have got various theories of light. So first we'll see what is the first theory about light. So that first theory says the light is the form of a particle. Now we are saying light is a form of waves, but in the first theory of light, which is a, well-known, accepted theory of light. So in that theory says that light is it is in the form of particles. Okay, so it is not a wave. It is composed of particles, tiny particles. Okay, so that theory has been framed by none other than our Newton. We know that Sir Isaac Newton, his contribution to the in the branch of physics is more, and he has given his theory about the nature of light also. Okay, so his theory is called as particle theory of light, particle theory of light, or it is otherwise called as corpuscular theory of light. So because this theory is otherwise called as corpuscular theory of light, because corpuscles, he named the particles as corpuscles. So named so from the name of the particles, the theory has also been named as corpuscular theory of light. Okay, so in that theory he says light is made up of number of particles of various sizes. Okay, and he could able to explain about the various properties like reflection and refraction of light. Okay, okay, and after that, the next theory after the Newton's corpuscular theory is Huygens theory. Okay, um, Hans Christian Huygens, he proposed a theory. He says that um, light is not it is not composed of particles. It is in the form of waves, because he says from by Newton's corpuscular theory of light, Newton could not explain the properties like interference and diffraction of light. So these are the other properties of light. As you learn about reflection and diffraction, there are some other properties of light which you call it as interference of light and diffraction of light. Okay, so these properties we'll be learning about them in detail in 12th standard. So about some of the properties of light, Newton's theory could not explain it clearly. So Huygens, he proposed a theory. So that theory called as Huygens theory of nature of light. So in that theory, he says light is a form of waves. But the thing he considered is light is a mechanical wave. You know that mechanical wave in the sense uh, that requires a medium for its propagation. So any a mechanical wave requires a particular medium for its propagation, for its movement. Okay. So in that way, Huygens theory failed because Newton is rejecting this theory because Newton he rejects it that saying that it could not explain clearly about the diffraction also, and it could not explain the polarization property also. So when Newton rejected it, and the followers of Newton also rejected the Huygens theory, they are not, because at that time Newton had such a fame that whatever he said it was taken to be right. Okay. So when Newton rejected this Huygens wave theory, then the follower of Newton also, they also rejected Huygens wave theory. Okay. And of course this is consideration like this is a mechanical wave, so that is found to be a wrong one also. So naturally people what rejected the Huygens theory of waves, right? Then comes the other theory that is called as actually Maxwell's electromagnetic theory. So in that theory, Maxwell's theory, he considered, and in that, no, Maxwell and Young, the contribution of Young is also important to this theory. They considered that light is not actually a mechanical wave; it is an electromagnetic wave. We know that any electromagnetic wave, it means it does not require a medium for its propagation. It means it can travel through vacuum. So now the theory what we are considering is actually, we call it as actually what light is a form of electromagnetic wave. And after that, this theory has been accepted and it could explain all the properties of light. But still, it could not explain one more property which is called as polarization of light. Okay. So about this interference, diffraction and polarization you will be learning in our higher standards. So this even there was one more theory after this Maxwell's electromagnetic wave theory. So that in that theory you consider again light to be as particles. Okay. So there light is considered as particles. Here the name of the particles are considered to be photons. This is actually this quantum theory. Light can be considered as photons. Okay, each photon will be having energy E is equal to h nu. So this is the last theory. Now you consider that light can be considered as waves as well as particles. In order to describe certain things, we will be considering them as particles also. That you call it as the particle nature of light. Okay. So about that you'll be learning in the higher classes. Now we consider light as a form of electromagnetic wave. It can travel through vacuum. We know that the speed of light in uh, a vacuum or air, it is 3 into 10 power 8 meter per second. The symbol for this is C is equal to 3 into 10 power 8 meter per second, right? So now the wavelength of visible light, since actually when you say it is a matter or a particle, you can talk about its other dimensions, like what could be the size of the particles and all those things. But here we say since light is a wave, what are the dimensions of this wave? So it has got three things. One is actually velocity, the other one is wavelength and frequency. So by saying about the frequency and wavelength, we will get an idea about the wave. Okay. So these are the three dimensions of light. Okay, velocity, wavelength and frequency. And there is a relation between these two. This velocity c is equal to nu lambda, where c is the velocity of light and nu is the frequency of light. It should be read as nu. So nu is the frequency of light, lambda is the wavelength of light. Okay. So these are the basic properties of light. Okay. Now we'll just have some idea about this electromagnetic waves. So we said light is a part of electromagnetic wave. Okay. So when you talk about, when you just say the word electromagnetic waves, it does not mean only light. It means including light. It means some 7 types of waves. Okay. So it means it refers to it means radio waves, it means microwave and infrared waves and visible light. So this is what the visible light we talk about. This is the range of visible light. and after that you have ultraviolet radiations, X-rays and gamma rays. So you can just divide this electromagnetic spectrum or electromagnetic waves under 7 categories. What are they? Radio waves, microwaves, infrared rays, visible light, and UV rays, X-rays and gamma rays, right? So this radio waves, here in this diagram it has been divided into two categories: long radio waves and radio waves which we use as signals in the radio and TV. Okay, so that is, so generally, but this can be put under a single category which you call it as radio waves. So these, all these 7 category of waves comes under the electromagnetic waves. So that is why we say, when you say light is an electromagnetic wave, we can say it light is a part of electromagnetic wave. Okay, so what is the wavelength range of light? You can say that from, that is visible light, from this 400 nanometer to 700 nanometer. Since it is wavelength, its wavelength is very less, so it will be in the nano, in the sense 10 power minus 9 meter, so it will be in the order of 10 power minus 9. So we are taking it as 400 nanometers to 700 nanometers. So that particular category we call it as visible light. Only this waves, this part of electromagnetic wave which has this particular wavelength from 400 nanometer 700 nanometer is visible to the human eye. That light we call it as visible light. Okay, only this is called as the visible light. Okay, so we know that, as you know, this thing Vibgyor. Okay, Vibgyor, this color. Okay, this visible light contains all this 7 colors, right? Okay, now you can just, if you want to know about the wavelength range, the radio waves will have the wavelength in the order of, it will be in the order of meters, 10 power 3 meters, and after that you have this microwaves, that will be in the order of 10 power minus 2, and infrared is 10 power minus 6, and visible light 0.5 10 power minus 6, or you can from in that range up. If you're saying in nanometers, you'll say as 500, that is, this is the midpoint of the visible light, 500 nanometer. Then ultraviolet 10 power minus 8 meters, and this X-ray 10 power minus 10, and gamma rays 10 power minus 12. Okay, and these are the approximate wavelength range. Radio waves, it will be the range of certain uh, buildings and other things. Okay, and you can know this. So this is an example of this. Okay, so the gamma rays, the size of the, I mean the wavelength range of gamma rays, you can compare it them to the size of the nucleus. We know that size of the nucleus is about from 10 power 12 to 10 power 15 meter. Okay, so this gamma ray, the wavelength of gamma rays can be expressed in terms of the atomic nuclei, whereas the wavelength of X-rays can be taken as the size of an atom, which is 10 power minus 10. In ultraviolet rays, it can be taken as the size of molecules, and the visible light, the wavelength can be taken as some of the protozoans, whose size is in the order of few microns. Okay, and infrared rays, the wavelength, it can be taken as a point needle thing. Okay, size. So this is what is the um, range. You can just have some idea about the things. For that, I've given you this range in the form of introduction. So this picture also will give you an idea about the usage of this electromagnetic waves. Okay, so this also you can just have a glance. And as I told you, this is a very important thing in today's session. Velocity of light, c is equal to nu lambda. C is equal to nu, you can write it like this, nu lambda, where nu is the frequency of light, lambda is the wavelength of light. Okay, so you can just calculate this. If a beam of wavelength 600 nanometer in air travels with the velocity of this power 8, 3 into 10 power 8 meter per second, find the frequency of light. So you can try out, you can do this calculation. C is equal to nu lambda. They are asking what is this nu. Nu is equal to C by lambda. Only thing is, when you substitute lambda here, you should not substitute as 600. It is given as 600 nanometer. So you should convert that into meter, because velocity you are giving in meters. So wavelength should also be given in meters. So 600 nano, we know it is 10 power 9 minus 9 meter. So when you substitute it here, you should substitute as what? This one, 10 power minus 6. 600 into 10 power minus 9 meter. then you'll get an answer. That will, in that case, that will be a correct answer. Okay, so try this sum and send the answer to me. Thank you.